Hello, this is the luckiest maths teacher in the world, and today we're going to conclude our lessons on index laws. So we're going to look at fractional indices and negative indices. So the other 6 index laws that we learned about in the previous 2 lessons are now on your screen. So for fractional indices, which we'll start with, they're not so naturally defined as, say, the other index laws, like the first one. So, for example, let's look at something like 2 to the power of a half, okay? So right now, we don't know exactly what this equals. Now, 2 to the power of a half doesn't have a natural meaning in the same way as, say, 2 to the power of 3, which was just 2 times 2 times 2. It equals 8, easy as. But what would 2 to the power of a half be? Well, what we're going to do is define it so that it is consistent with the other index laws. So we know, for example, that this index law, the first one, is true for all whole numbered indices. So we're just going to extend that when the indices are not a whole number. So let's use this law. So let's say I have 2 to the power of a half times 2 to the power of a half. Okay, now by the first index law, when we're multiplying the bases, we keep the same base, and then we add the indices. So this should be 2 to the power of a half plus a half. Now 2 to the power of a half plus a half is just 2 to the power of 1, which is 2, right? So therefore, we have, I'll write it again, 2 to the power of a half times 2 to the power of a half equals 2, right? But this means that we're multiplying a number by itself to get 2. Now, there is only one such number for which that's true. There is only one number that you can multiply by itself to get 2. I should say there's one positive number. That number is 1.4142 and so on. It's irrational. We write it usually like this, root 2. I know that root 2 times root 2 equals 2. Root 2 times itself equals 2. So what does this mean? It means that if this is true at the same time that this is true, then it must be the case that 2 to the power of a half equals the square root of 2, right? But I could have chosen any number here, any positive whole number, and this would have been true. So I could have chosen, let's say, 4 to the power of a half. I know 4 to the power of a half times 4 to the power of a half equals 4. So I've got something times by itself to give 4. But I know that it's 2 times itself that equals 4. So therefore, I have 4 to the power of a half equals 2, which is the square root of 4. Okay, so I'm going to rub this out, so please copy it down if you need it. So what we've just discovered is that if the other index laws, particularly the first index law, is true for any power, even those that aren't a whole number, we have 4 to the power of a half equals the square root of 4, which is 2. We figured out 2 to the power of a half must be the square root of 2. So let's write this generally. A to the power of a half equals square root of A, okay? Now let's look at something like a to the power of 3 on 2. So to be consistent with the third index law, which is this one here, I know that I can write a to the power of 3 on 2 as a to the power of a half cubed. Or I can write it equivalently as a cubed to the power of a half, because I multiply the powers, and this will give me a to the power of 3 on 2. So therefore, a to the power of 3 on 2, if I use this equation here, I get a to the 3 on 2 is the square root of a, which is a to the power of a half cubed. If I use the second one, I get that a to the power of 3 on 2 equals square root of a cubed. In fact, this and this are the same thing. So I could have chosen any number on top. I could have chosen a to the power of 5 on 2, a to the power of 6 on 2, 7 on 2, whatever. So I have this rule because I'm using the first and third index laws, because I'm saying that they're going to be true even when the power is a fraction, a to the power of, let's say, k on 2 is the same as the square root, that's where the on 2 bit comes from, of a to the power of k, right? So again, I'm going to rub this out, so copy it down if you need. So this is my discovery so far. I found that a to the power of k on 2 equals the square root of a to the power of k, right? Now let's look at if I didn't have 2 as the denominator. So I can use the same logic. So using the first index law, I know that a to the power of a third times a to the power of a third times a to the power of a third equals, so I keep the same base, and a third plus a third plus a third equals 1. So by the same logic that I used before, because I'm multiplying a number by itself 3 times to get a, the only way that works is if a to the power of a third is the cubed root of a. So a to the power of a quarter would be the 4th root of a. And just like the trick that I've shown up here, if I had something like a to the, let's say, 7 on 3, by this index law, the third index law, that would be the cubed root of a to the power of 7, okay? So we're ready now to write a general rule. So I'm going to write the second last index law. So 7 is a to the power of, let's call it b over c, equals the c root of a to the power of b. Okay, so just like, for example, if I had 3 to the power of 5 over 4, using that law, that would be the 4th root, because 4 is on the bottom of the fraction, of 3 to the power of 5. Okay? So now let's look at negative indices. So again, let's try a similar trick. So let's say I have 2 to the power of negative 1. Now it's probably natural for you to think, oh, this is be negative 2, but then it wouldn't be consistent with the other index laws. So I know, for example, that 2 to the power of negative 1 times, let's say, 2 to the power of 2. By the first index law, that's 2 to the power of negative 1 plus 2, which is 1. But I know, of course, that 2 squared is just 4. So I can rewrite this as 2 to the power of negative 1 times 4 equals 2 to the power of 1 is 2. So we can rearrange this equation, divide each side by 4, and we get 2 to the power of negative 1 is 2 over 4, which equals a half. Similarly, I could have done 2 to the power of negative 3 times 2 to the power of, let's say, 4 equals 2. So 2 to the power of negative 3 equals 2 over 2 to the power of 4. So 2 over 2 to the power of 4 is 2 over 16, which is 1 over 8, which is 1 over 2 cubed. So in order to be consistent with the first index law, we have that a to the power of negative b equals 1 over a to the power of b. And that's because we know a to the power of negative b times a to the power of positive b is 1. Or a to the power of 0 from the first index law. So therefore we can rearrange that equation and get this. A to the negative b equals 1 over a to the power of b. So that is our last index law. So all of these index laws are written for you on your sheet. So now we're just going to do a couple of quick examples. So let's say we had the question where we had to evaluate 2 to the power of negative 5. Well, that would just be 1 over, now this is how you do negative powers. You put a 1 on the top, and then you write the base and exponent on the bottom, but with a positive power. So this is 1 over 2 to the power of 5, which is 1 over 32. So if you had something like this, x times y to the negative 2, this is the same as x times, so the negative power, we put 1 on the top, and we write the power on the bottom with a positive power. So that's x times 1 over y squared, which is x over y squared. So as you can see from this example, when you have something like this, anything that has a positive power goes on top. Anything that has a negative power goes on the bottom, but you write it with a positive power. So for example, 3a to the power of negative 5 would just be 3 over a to the power of 5. If you had something like where the negative power was already on the bottom, like 1 over a to the power of negative 2, then that just goes on the top with a positive power. So this would be 1 over, now a to the negative 2 is 1 on a squared, so 1 divide 1 on a squared is a to the power of 2. So basically, negative power, if it's on the bottom, move it to the top. If it's on the top, move it to the bottom. And we always write it with a positive power. Okay, so to show you the other one, so let's say I have 81 to the power of 1/4, and I want to figure out what that is. So that would be the 4th root of 81. So you got to either use your calculator or you think to yourself, what number do I multiply by itself 4 times to get 81? And the answer there is 3, because 3 to the power of 4 is 81. So a to the power of, let's say, 3 over 2 is, as similar to what I showed you before, that would be the square root, square because there's a 2 on the bottom, of a cubed. Okay? So please ask if you have any questions. Other than that, this has been the luckiest maths teacher in the world. Have a great day.